Okay, let's look at page 2. We're going to start with parallelograms. Now think of the properties of a parallelogram. You know that opposite sides are parallel, so BC is parallel to ED, EB is parallel to DC. And then we know opposite sides are congruent, so BC and ED are congruent, BE and CD are congruent. Opposite angles are congruent, so angle C and angle E are congruent, angle B and angle D are congruent. Consecutive angles are supplementary, and that's all the way around. So D plus C, C plus B, B plus E, E plus D will give you 180. And then your diagonals are going to bisect each other. So here we're told that EB is equal to 16. That means that DC will also equal 16. Then we're told that ED is equal to 25. So BC is also equal to 25. Then we're told BF is 11. So that means that FD will also be 11 because diagonals bisect each other into two congruent segments. EC, which is the entire diagonal, is 34. So if you half 34, that'll give you 17 for each part of your diagonal. So BC is going to be equal to 25. BD is going to be equal to 11 plus 11, which is 22. FC is going to be equal to 34 divided by 2, which is 17. And then CD is 16 units. So those will give us the sides that we were asked to determine. Now, let's look at our angles. The first angle that they're asking us to look for is EDC. Let's go ahead and fill in our angle measurements. The angle BED, BED is going to be this angle right here. It's the whole angle unit. So that's angle E is 55. So across from it, angle C is also 55 degrees. Then we're given CDB. So here is C, here's D, and here's B. So this part right here is 67 degrees. Okay, by alternate interior angles, remember opposite sides are parallel, and this is our transversal. If this is 67, then I can go up here and make this part 67 as well. And then BCE, BCE, which is this part right here, is 24 degrees. Okay, so again, alternate interior angles. If this is 24 degrees, then this is 24 degrees. Okay, so because this whole angle is 55 degrees, I can do 55 degrees minus 24 degrees is 31 degrees. And then by alternate interior angles, this one is also 31 degrees. Now let's we know that angle B and angle C are consecutive angles, so they're supplementary. 180 degrees minus 55 degrees is 125 degrees. So angle B and angle D are both 125 degrees. Well, that's the whole angle. I have part of the angle right here as 67 degrees. So 125 degrees minus 67 degrees is going to give me 58 degrees. Then by alternate interior, this one is also 58 degrees. So when we're asked to find angle EDC, we found all the angles, I do believe. EDC is the entire angle, so that's 125 degrees. EBD, so here's E, B, and D, so that's going to be this part of the angle right here, 67 degrees. The next one is BEC, so here's B, here's E, and here's C, so we're looking for this part, which is 31 degrees. And then DBC, here's D, B, and C, is going to be this part of the angle, which is 58 degrees. Okay, looking at number 15. Still dealing with a parallelogram, so remember opposite angles are congruent. 8x plus 17 is equal to 12x minus 39. Let's subtract 8x from both sides to get 17 is equal to 12 minus 8, which is 4. That's going to leave us with a two-step equation, so add your 39 to both sides. and then divide both sides by 4. And we'll get x is equal to 14. So let's plug in. I'm going to plug in for angle K. So the measure of angle K is equal to 8 times x, which will be 8 times 14, plus 17. So 112 plus 17 is 129 degrees. So that means that angle K is 129 degrees and angle M is 129 degrees. We're asked to find angle N. Well, K and N and M and N are supplementary to each other. So I can do 180 minus 129, and that gives me 51 degrees for angle N and angle L. So the measure of angle N is 51 degrees. Number 16, the measure of angle R. Well, we're given angle U and angle T. Those are consecutive angles, so I know they're supplementary. So 5x minus 6 plus 14x minus 4 equal 180 degrees. So what I'm going to do here is combine like terms. 5 plus 14 is 19. Negative 6 and negative 4 is negative 10. Let's solve for x by adding 10 to both sides, and we'll get 19x equals 190. Divide both sides by 19 to get x equals 10. If I know x equals 10, I can go ahead and find angle T. The reason I'm using angle T is because angle R and angle T are opposite each other and therefore congruent. So to find the measure of angle T, I'll do 14 times x, which is 10, minus 4, or 140 minus 4, which is 136 degrees. If T is 136 degrees, then R is also 136. So the measure of angle R is 136 degrees. Now on number 17, I've got another parallelogram. It tells me ED is 7x minus 13. So that's going to be this section down here, which means if ED is 7x minus 13, then BE will also be 7x minus 13. And then BD, which is the entire length of the diagonal, is 16x minus 38. So, if you remember, in a parallelogram, your diagonals bisect each other in half. So that means 7x minus 13 plus 7x minus 13, or 7x minus 13 times 2, is going to equal the entire diagonal. So distribute and solve for x. We're going to have to subtract 14x from both sides. That's going to give us negative 26 equals 2x minus 38. Add 38 to both sides and divide by 2 to get x is 6. Now we're asked to find the length of BD. I know that BD is 16x minus 38. So 16 times x, which is now 6, minus 38, multiply 16 times 6 is 96, minus 38 gives me BD equals 58 units. Okay, now our next quadrilateral is our rectangle. Let's remember the properties of a rectangle. It's going to have the same as a parallelogram: opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals are going to bisect each other. But in a rectangle, we're going to throw in the 4 right angles in each corner, and now your diagonals are congruent. So if your diagonals are congruent, when they bisect each other, each part will be congruent. So here we have AD is 9, so BC is also 9. AC is 22, so if you take 22 and divide it by 2, you'll get 11 for every part of your diagonal. Because again, diagonals are congruent and they bisect each other. So if you get that AC is 22, so AE is 11, EC is 11, DE is 11, and EB is 11. Then you've got the measure of angle BCA. BCA is this angle right here. That's 66 degrees. Find each missing measure. Okay, so to find BC, we already know that's 9. Okay, to find AB, which is going to be one of the sides of our rectangle. Okay, so in order to solve this, what we're going to do is we're going to have to use the Pythagorean theorem. Okay, so let's envision what this looks like. This is what we're looking for. BC is 9, and then 11 plus 11 is 22, and I know the corner is a right angle. So AB is going to be one of my legs. So A squared plus B squared equals C squared. So X squared plus 81 is equal to 22 squared. I forgot to write that down. Let me calculate that real quick. 22 squared, 484. Subtract 81 from both sides, and you'll get x squared is equal to 401. Now take the square root and let's go out 1 decimal place, and we'll get x is 20 1/10. So that's AB, but remember it's also DC because opposite sides are congruent. Then we're asked to find BD. That's going to be 11 plus 11, which is 22. And then EC, which is going to be part of your diagonal, which is 11. Okay, so we get 9, 20 1/10, 22, and 11. Now let's talk about these angles. We're looking for angle ADC. ADC is the entire angle, which is 90 degrees. BAC, which is going to be this part right here. Okay, so if you'll think about it, I've got this part down here, which is 66 degrees. 90 minus 66 is 24 degrees for this part down here. Now, because I have opposite sides are parallel, this is my transversal. Alternate interior angles tells me that this angle is also 24 degrees. So BAC is equal to 24 degrees. Now we're looking for CDB. CDB is this angle right here. Okay, now notice, because our diagonals are congruent and they bisect each other, these two lines are congruent. Right here we have an isosceles triangle. So if the two sides are congruent, then the base angles are also congruent. So CDB is 24 degrees as well. Finally, we have AEB, which is going to be this part of the angle right here. Okay, so once again, these two are congruent, making an isosceles triangle. So if this is 24, then this is 24. I know 24 and 24 is 48, so because this is a triangle, I can do 180 minus 48 gives me 132 degrees for AEB. Okay, now let's look at number 19. We have another rectangle. PR, which is my diagonal, is 9x plus 1. QS, which is my other diagonal, is 13x minus 11. Well, in a rectangle, diagonals are congruent, so I can take 13x minus 11 and set it equal to 9x plus 1. Let's subtract 9x from both sides. Add your 11 to both sides. And divide both sides by 4 to get x equals 3. So if I know that x equals 3, I can plug it in to PR or QS. Since I'm looking for TR, I'm going to plug it into PR. 9 times 3 plus 1 is 27 plus 1, or 28. That's the length of PR, which is my entire diagonal. Diagonals bisect each other, so PT and TR are congruent. So to find TR, you're going to take 28 and divide it in half to get 14. Number 20, DEG, which is this angle right here, is 4x minus 5. FGE, which is this angle right here, is 6x minus 21. These two angles are congruent to each other by alternate interior angles. So 4x minus 5 equals 6x minus 21. Let's subtract that 4x from both sides. Add 21 to both sides. And divide both sides by 2. So I get x is equal to 8. Okay? So I can plug it into either of my angles. 4 times 8 minus 5, or 32 minus 5, is 27 degrees. Okay? That's going to give me this angle here and this angle here. We're asked to find DGE. DGE is this angle. So if this part is 27 degrees, I know the whole angle is 90. So 90 minus 27 is 63 degrees. So the measure of angle DGE is 63 degrees.